Hi, everyone. I'm Patrick McFadin. I am really happy you're joining us on a Friday night. And by the way, I'll let everyone know in a Slack today where I'm like, oh, there's no more than 40 people going to show up. Yeah, I lost totally. I publicly apologize, Dinesh. You want to get on the mic and mock me? Go ahead.
No, I'll just do that privately.
On a microphone, yeah. Yeah, I said I was happy to be wrong, and I still am. So I gotta know. I mean, you all came over here on a Friday night. Besides the fact you probably didn't have anything else going on. No, all right, no. I wasn't gonna. I'm still bitter that I lost. How many of you? Your job is running a Cassandra cluster. That's a lot of hands. How many of you develop code using a Cassandra cluster that somebody else runs? How many are you like, I heard about this Cassandra thing and I want to know more about it? And you now hold on. Now I know there's liars and you're like, oh, I've heard about that. Yeah. All right, cool. Well, we're very happy you're here because we haven't had a meetup in the Bay Area in a long time. And a lot of us were just at Community Over Code. That's an Apache conference. And that was more of like the builders, people building Cassandra and talking about like things like repairs. But you know, it's really cool because one of the things I love about Cassandra is it's running the world right now. Did you know that? I mean, it's the biggest database you probably don't really talk a lot about. And so it's good when we're talking a lot about it. So tonight I'm going to be talking about the other thing you probably have heard about, AI, a thing. Yeah. Gen AI, ever heard of it? So I'm going to start off with a little problem statement here. So I'm going to go over here. Yeah, so we're going to watch a little Netflix, chill. That's what you do on a Friday, right? Now I'm going to point out a huge problem here. Anybody from the Netflix search team here? Sweet. Yeah, I'm good because I would have gotten kicked out. All right, so I'm going to try a little something like a movie with a cat as the lead. What is that? I'm sorry. That is terrible. I mean, I have, you know what, here, you know what oops, sorry. You know what I'm going to have to do is this. Cat.
You're lost on the screen. You know what?
Yes, stop.
Oh, I love Sorry. Is that what happened? Is it like
Is the Netflix search team part of this?
yeah, I know, you know what it was. Yeah, that was my problem. I got it. I just had to hack past all the Netflix censors. So I typed in one word and I got something, but you know what? 1999 called, they want their search back. So I'm gonna show you how we're gonna fix this, okay? Together we're going to make Netflix better. Yeah, see, that's the way to start off, like mock your host. By the way, big thank you, Netflix, for hosting us tonight. Thank you very much. And it's very generous. And the food and everything else. So see what I did there? All right, let's get so let me fix this. The other thing is and I'm gonna put this QR code at the end, but I want everyone to take this survey if you have not. And there's prizes, there's joy, there's excitement. This is the Apache Cassandra user survey. We do it every year. Really important because it's asking easy questions like, what are you interested in? Where are you at in your journey? How do you deploy Cassandra? Things like that. And it's always interesting to see how it evolves throughout the years. So, and I'll show you at the end. And at the end, I expect to see all your cameras up because I know every single camera in the world does QR codes now. I saw that on Veritasium. I know things. All right, so let's start out with this. Everyone knows what vector search is, right? Yeah, no. See, that's the thing. I've noticed that data people, like, there's a lot of people who are really excited about Gen AI and vector search. You're probably not one of them. You know, especially when you work in data, you're like, oh God, another thing to do data with. And it's the same thing over and over again. Vector search has kind of whiffed past a lot of people. Like, I don't even know what that is or care. So I'm going to give you a little bit of, if you know what it is, I'm sorry if I make it too basic, but I want to show you what this is. So I just demonstrated part of the problem. Vector search is about finding data. So we're used as in databases, we're used to the exact match where we say, oh, here's a key where, value equals 1. That's the classic way to find data. Any database will do this. Then we get into this keyword stuff like Elastic, Lucene, Solar. I want to find the word cat. See how I tied all this together? And I wonder what Netflix uses for search. Probably Elastic, because it's a keyword search. Now, keyword search is really cool because it finds things in documents, it finds things in your database. You can do index searches, that sort of thing. Semantic search is this next paradigm that we're talking about, and that is finding meaning in the thing that you ask for. And this is how more of like how humans work. When we talk, we usually have some context we share, or when I say, find me a movie with cats as main characters, there's context to that. It's not some keywords. I'm not pulling out the word cat, although the cat is important. Well, that's what vector search really enables, is this new kind of search. And that's why it's really interesting with language models, because language models that's the interface that people are choosing right now with Gen AI. And language models are about context and finding things and trying to give you the right answer, hallucinations, all that fun stuff. So the important beginning of everything that's in vector search you have to understand, vectors are created. We have to create vectors. And this goes back, and this is machine learning people love to talk about this, but these embedding models have been used and created for a long time. The transformers have been changing this. Transformer paper at Google has made this really a big deal now, because it's taking things like a phrase or titles and descriptions, running it through an embedding model, and then getting these vectors out. And it's just a really long array of coefficients. And those dimensions can be based on whatever, like the model can spit out a lot of numbers in an array, 200, 1,500 numbers in the array. But that number, that vector, represents what the model sees in that phrase. And that's where some of that magical looking stuff happens. Like, how can it find things when I say, find me movie with cats as main characters? And this is how it does it. In vector space, which is multi-dimensional, not 3D, that's only 3 dimensions. Some of these could be 1,500 dimensions. So don't even try to visualize it. And I'm not going to put this on a slide. But these dimensions are getting you somewhere in some space. So whenever I put that, find me, something about cats, in this vector space, whenever you create these vectors, and I'll show you how we do that, things kind of sit in different areas. So for instance, all kinds of things about books are over here on the left, and then there might be some cat books inside there. Yes, I had to go look for cat books. And then on the right over here, there's stuff about movies, and inside of that movie cloud, there's some cat movies in there. So those are over there. So whenever I put in that vector, what it's doing, that orange dot there, is exactly what it came up with when it ran my phrase through that model. And then we get to ask the question, all right, based on this location that I gave you, what's nearby? And give me the closest thing. This is what we call approximate nearest neighbor, right? That's why you call it A&N search. But it opens up the doors for all kinds of stuff, because then you can do things like image searches. Is this a hot dog? Is it not a hot dog? Is this place close to this place in real physical place? Are these words, or are these phrases, or are these, like, this entire book similar to this entire book? Similarity search is very cool for a lot of reasons. And what it fuels is this thing that everybody's talking about right now. Retrieval augmented generation, RAG. This is what it is, right? But why is this important? Well, it's because whenever when we work with large language models kind of suck, right? They just, you ask it a question and it will give you a very probabilistic close answer, right? And the problem is language models are really good at communicating, some with reasoning, but they don't have knowledge. Yeah, there's some that do, some that act like they do, but that knowledge is important. Let's say, for instance, you have very important information that you want to have an interface to. Say, this is what everyone's doing, building chatbots, right? You want to chat with your corporate data. Glean is making an entire company on this. But like your internal data, you're not going to go bake that into an LLM. That's a very expensive proposition. This is why OpenAI got like $150 billion of investment, because they're going to burn that on GPUs. Where that money's going? Right down the road to NVIDIA. There's like a truck that's going there every day. And so we don't want to put all that knowledge in the LLM. We just want to use the LLM for communication. So this workflow that I have here. So when you ask the question of that, you're using that question to do a vector search on your Cassandra database, because that's the only vector database on the planet right now. I'm kidding. But if you're in a Cassandra meetup, what else do you think I'm going to talk about? It will return back a result set of things that are close to that question with a confidence score to it. And you'll use that result set along with the prompt. Then you'll take it over to the LLM. So the LLM will have some context, like some actual information, some right information, and it'll come back with an answer. And this is really how chatbots are supposed to work. And so when it'll come back and say, oh, here's some popular movies based on this, and then it'll give you the order, like Cats is the top one, and then A Talking Cat is the second one. The LLM didn't have to store that information. It's just being the conduit to the human. That's the human interface. So this is how it works, but it also demonstrates how useful this actually is. So that's the beginning of vector search. That's all you need to know. There's a lot more to it, but that's really the key of it. This is built into the database, but there's some things around Cassandra that we want to talk about, like how it's implemented. So JVector. JVector is a project that was started by Jonathan Ellis of OG Cassandra fame. He's got Cassandra 1. He was one of the first people to work on Cassandra. Well, he's still here, and he was one who started JVector. And JVector, yes, it was a separate GitHub, but it is integrated into Cassandra, and I'll go more into that in a bit. So this is the 5 hard problems, right? And it should be familiar for people who work with Cassandra. Cassandra is a database that really holds on to these important tenets like scaling and fault tolerance, multi-data center. All that stuff should be like just non-negotiable. But what Jonathan saw was that, hold on, vector search is another scale problem that we will hit our head on pretty quickly. And it's a different kind of data problem, but it works well with Cassandra. And I was involved in some of those early conversations. It was really funny because we're like, this would be a totally good problem for Cassandra. I mean, in the way that Cassandra works, we've already started seeing like some glimmers of the better ways to do search with SAI, that this just made sense. And I think you'll agree, it's a great database with potential, and it's turning out to be actually one of the best. So some of the things like the scaling out, garbage collection, not Java, garbage collection. It's like when indexes need to be updated quite often. That's an important thing. Effective use of disk. You can imagine that these vectors, as they get larger, could really consume a lot of disk. And it could be really chatty with the disk as well. One of the things about vector search that's turning out to be critical is everything has to fit in memory. And I'll explain how we address that problem. This hybrid search concept is really important as well, because whenever we do search, we don't just look for a phrase. We may want to add that into something. We want to partition the data or attach it to some sort of predicate in the search so you can narrow down the search. If you have a petabyte of data, which apparently Dinesh does, you do not want to look at all petabyte of that data for this one little thing. You want to be able to partition it down. Using predicates is really important. Hybrid search is important. And finally, concurrency, which we all agree, and this is a thing that Cassandra does really well, is concurrency is key, because Cassandra is a database that you put as close to your users as possible. And that's where that concurrency problem always winds up. You just get pounded all the time. Okay. So that concurrency problem, now I have this asterisk thing in here because that was the only benchmark that I had, but I'm using it to point out a problem. So I put this yay SAI thing down here. What is this pointing out? Well, I got theme music right on. What is this pointing out? The concurrency issues with vector search up to this point. So vector search is not a new paradigm in data. It goes all the way back to the Facebook. There's like a batch protocol that indexed vector data, but it was really grounded in batch. So you dump a bunch of vectors into a file store, you run an indexer, then you can do a search. Okay, so that was very batchy. Getting away from batch is a hard problem. Funnily enough, we solved that with SAI, or actually we went back all the way to how Cassandra does indexing. And that's the indexing on write. You don't put the data to disk and then an indexer comes along later. That's that index lag that just doesn't work in an application database. So what this graph is showing actually is like Pinecode does batches. As soon as you put the data in, there's an indexer that comes on and picks it up. And that's great if you don't care about the fastness of your index. Like if you don't need that data available to you when you do the next read. But if you don't, that index lag is going to get you. And Cassandra, out of the box, just does this because of the way it was built. We solved that problem like 8 years ago. So yay team, good job. All right. So just like what changed in Cassandra? So there's a few things. First of all, we have a new type, a vector data type. Thanks, David, for adding that. I remember when you did that. And the vector data type has two fields. There's the float, and there's only a float, but that's all it is. And then it's size, the dimension size. Now I put 5 here, but it'll never be 5. Dimensions, that amount of dimensions have to match the embedding model that you're using. So for instance, if you're using Ada from OpenAI, it could be 768 or 1542. It has to match up. But that's what that number represents. But if you notice, like you're creating a table here with a vector in it. It's not just a vector database. This is a database with a new feature. And that's how we see Cassandra showing up at the Gen AI party is we just added a feature. By the way, every database has added vector now. SQLite finished the deal like a month ago. So now that's it. There's no more databases that don't have vector. Oh, wait. Microsoft Access does not have vector search. I hear they're adding it. But that'd be cool, right? When you're writing your Visual Basic 6 code and you're like, I wish I had vector search. I laugh, but there probably are. Oh, Microsoft, I love you. But so when you have these data models now, that you're just adding a new field. So you can think of like in this product table, now we have name, description. These are like real data parts. But what if I wanted to find products? This is actually a really cool use case you can use. This is a data model that is being, the Wikimedia Foundation is doing something similar with Cassandra, by the way, where the articles that are stored there, they use vector search to help you get there, but the real data is like the article, and that's co-located with the vector search terms. And then you create an index, and using storage attached index, SAI, and that's why this was an easy feature to add, because we had already done all the hard work. Secondary indexes, now the storage attached indexes, all that hard work that was done to make indexing really clean and easy and part of the coordinator and a part of the right path, we just put this extra little thing on there for vector, and it makes it work really well. That's why it was a very easy feature to add, and it happened quickly. But when you create an index for it, what you're doing is you're making it so that field is indexable. It does not index, it does not create vectors in your database. And we're going to go through this, right? Because I think this is a common misconception. Oh, does it take a field from my database and create vector embeddings from it? No, it does not. We'll get there. And then finally, when you do like a search, it's there's a new syntax. It's you do this item vector ANN of, and you provide it with an embedding, like a vector. So you're saying, hey, anything that's close to that vector coordinate, get back and give me results back. And it could be, you could have a limit 5, a limit 10, whatever you need to do. But it's just part of the select query. And what you'll get back is something that's similar. And there's different, I didn't go into all the modes, but there's different ways to do an ANN search. There's dot product, there's cosine. These are all in the documentation. If you're interested in getting into vector search, it's this big. It's not that much, but there's some things you need to think about. For instance, cosine is very flexible, dot product is not, but dot product is faster. Hey, we all have something new to learn, so we all have jobs still. Now, this is what I was talking about, working with vectors. Here's some key things for your success. The embedding model is kind of the key, the middle of the universe when you're working with vectors. You have to use the same embedding model whenever you first load, like you do an insert of the data, and you have to use that same model when you do a search for that data. That model has to match up. If you'd use a separate model to create the data, the vector, and then another one to search, you will not get what you want. And the other thing that's important is the database does not create those embeddings. You have to, whenever you insert the data, you just insert a vector. You're not inserting, like you're not saying, oh, and go create the embedding once it's in there. It's not like whenever you create index, it creates an index file for that. No. It just indexes the vectors that you give it. Now, like with Astro, like our database service, data stacks, we actually had to build a little sidecar service now, like that will, go out to like NVIDIA and create an embedding for you. So that's like a hard feature we had to add into our system. Why? Because everybody got tripped up on this one. They're like, I just put data in there. Why there's no vectors? You have to bring your own. What? We're all learning. But that's just a really important thing. Working with vectors, just understand this. Okay, so what about that JVector sauce? And you should be very proud as a Cassandra community. We're doing great. I'm just going to pause here for a minute. I'm very excited where the Cassandra community is going. I just wrote an article, a blog post about how the CEPs are really moving things forward. I'm really excited after this week. I mean, we have some really great CEPs coming. The CEP is a Cassandra enhancement process. And as a community, it's really interesting. I look around here and I see tons of coworkers. Dan is the only guy I work with. Dan and I are the only ones from DataStack, but I see tons of coworkers here, like Alex and Vinay. I mean, we all work on Cassandra together. And if you feel like contributing, we would love to have you. But it's a really cool project right now because I feel like we're moving really fast. And it always has been a cool project, but I just am excited about where Cassandra is going right now. Okay, so JVector in a nutshell. Why has it got sauce? Well, there are a lot of ways to do vector search and indexing in a database in a data world. But what does JVector bring that's so cool? Why do people love it so much? Well, first of all, is this problem of efficient compression. As I mentioned, you don't want to read the indexes off the disk. That's when you're talking about a 1,500 term vector per table, per column. Every record now has its own 1,500 term vector that needs to get read in. That's going to get really heavy on the disk, and that will slow everything down. So efficient compression means compressing it and putting it into memory. We really try to put as much of the index into memory as possible. And when we're talking about a JVM process, you're like, but there's some really cool techniques. First of all, Microsoft wrote this paper called Disk ANN. I'm pretty sure it was Microsoft Access. Kidding, that was a joke. Just making sure you're still awake. And then there's this word called quantization. Now, if you get into the AI ML, that word shows up a lot, and you have to act like you know what it means, right? Because people say, "Oh, do you use BQ or PQ quantization?" I have to admit, I was like, "Why is this important? Why are people arguing on Twitter about quantization?" Well, really, all a quantization is a way to compress vectors, and there's two methods that are competing. One is binary quantization, which sucks, and product quantization, which rocks. JVector uses product quantization, and really, what that means is it compresses. It's a very efficient way to compress down the vector, and quantization, that process, is generally lossy, so you'll lose resolution. Well, and that means that a lot of indexes that are doing reads have to reread the data a couple of times to get the full resolution to make sure that you got a good solid lock on where that thing is in vector space. Well, with product quantization, not only is it faster, it's smaller, and it's less lossy. So that means less reads on disk. That's where the disk A&N paper came. It's like, hey, let's keep you from going to disk. So that's a big part of JVector, by the way. I mentioned before, I'm going to mention it again, the SAI integration, super cool. It's a baked part of Cassandra. It's been worked on for 4 years. It's in 5.0 now. There's a lot of contributors to it. It's just getting better and better. There's a Jira out there now for it. But integrating with SAI makes indexing work really well. And then finally, it was a non-negotiable. It has to be on JDK 21 plus. And the reason is because of the way memory management works. Remember I said those things have to be stuffed into memory? Well, you're going to have some big heaps. You should never have a garbage collection. Shenandoah and all that, ZGC, amazing. And then finally, some of the extensions that are in JDK 21 with SIMD are also amazing. When you're working with this kind of data, you do want to use like SIMD for that stuff whenever you're doing compression of vectors. Intel processors, you just hand it a bunch of vectors and it'll do the compression for you on silicon. So JDK 21 unlocks that. If you're not on 21 yet, I know we're on as a project, we're at 17, but we'll be on 21. After this week, we'll probably be on 21 by the weekend. But it's really pretty amazing. The JDK has really improved a lot when it comes to memory. Anytime I hear anyone say, oh, Java, JVM has so many memory problems, like go back to 2010. Yeah, exactly. And if you have a book on that, it'd be nice. Oh, you're gonna write a book on that, right? Yeah, it's pretty amazing. So how's it going? I'm gonna talk about it. I mean, because I work at DataStax, I can talk about, hey, we have customers, but we actually have people using it on Astra, which, by the way, if you want to know, Cassandra and Astra, same thing. It's not like it's pretty much Cassandra 5, but we really actually have, yeah, that moves, by the way. That isn't you're not hallucinating. That is an animation. First time I saw that, I was like, oh no, I lost it. No, it's an animation. We have a couple of, these are production customers that are let me talk about them, but these are pretty big. I mean, Physics Wallah in India is massive, and they're getting like bazillion hits a day on their vector search. They have this thing called AI Guru that does this personalized tutoring stuff, and it's very. I mean, they are really running with it. And then another one is called Penny. It's from Priceline. So whenever you book a trip with Priceline.com, you can say, oh, hey, what's to eat around my hotel? Or there's things to do in the city. You can have a chat with your own itinerary. That's just a RAG application. By the way, notice these are both chatbots. If you haven't not done anything with AI, I'm going to implore you, beg you. First thing you should do is write a chatbot. I know everyone's like, oh, you should do an agent. No. Do a chatbot. Do a chatbot, because chatbots are hard. And then you'll learn a lot. And then you can go do the fancy stuff. If you try to like run, you're going to fall down. And that's my best advice for anyone who wants to get in AI. But yeah, it was really cool. Like these guys the Priceline put this thing online and they saw some immediate benefit. And what is it doing? It's using RAG and vector search on data that you put in. So it's very personalized. And then here's like the really cool thing. And I know it's like, Forrester, what? This just came out. And it's DataStax, but just put Cassandra in there because they only look at vendors. There's only 2 of us up there. Milvis, Zill's team. Congratulations. That was pretty awesome too. I love the Milvis guys. It's Milvis and Cassandra were the top ones. Look at the other ones behind it. Like there's AWS, Microsoft, Pinecone, and you know who's not on there? Anyone running PGVector. They are hating life right now because PGVector is so terrible, but it's like it's default, right? Oh, I have Postgres. I guess I'll just turn this on. Oh, the tears. Anyway, but I thought this was really cool because, and yeah, if you're not interested in like the Forrester or Gartner stuff, but that was a big deal that I think it's a big deal because all my years of Cassandra stuff, I've never ever seen anything like this. They always are like, oh, Cassandra, it's only good for like the trashiest data because it's eventually consistent. Why would you put anything real in there? They're getting over that, by the way. And thanks to Accord, they're really going to get over it. Can't wait. So here's a quick little demo of the way search should be. There you go. See, you can do it. You can do it. Yeah. Well, there's a lot more to this, but this is a little demo. I did not want to do a live demo here because after a week of watching people fail at community over code, I'm like, I'm bringing a video. But yeah, this is really cool. This is on GitHub. It uses Cassandra on the back end, but what it loads the TMDB, the movie database. It loads that in. It does vectorizes or creates vector embeddings on the descriptions and titles and things like that. And you can ask it questions, but it also has like thumbnails and stuff like that. So, but you can ask it a question like, hey, are there any videos with cats as the lead character? And it'll be like, why, yes, there is. And here it is on Netflix. Oh. All right. No. I know, I'm almost done. All right, so what now? I'm at my last slide, okay? You know why? You know it's the last slide? Because look at that. Take the Cassandra survey right there. So I want to see those phones up. So what now? There are so many choices if you want to work with vector data. On the self-managed side, it's in Cassandra 5. It's out there. You can download it. There's Docker. If you're into Kubernetes, there's Cassandra. It's all in there. DataStax has a branch. Dan, does that URL look familiar? Dan, that's Dan's thing. So everybody has, by the way, if large Cassandra shops all have a fork, that's the truth. And and what we do is we put our features into it and then we push them upstream to the Cassandra project. Well, this is DataStax feature branch. This is where we start doing things. And so this is what we work on, and this is what's in our products and things like that. It's all open source, but it isn't the same version of Cassandra that you're going to get off of Apache. It's some version that we're working on, but it also has the latest whatever we're working on, JVector. We also have it in our enterprise products. And if you just want JVector, nothing else, that's a GitHub. So Jonathan Ellis has his JVector out there. And that is the tip of the spear. And that last bullet is pretty cool. Coming soon to OpenSearch. Yeah, we just, we're working, Jonathan's working with the OpenSearch team. They're like, yeah, HNS-W sucks. And if you don't know what HNS-W is, it's one of the algorithms. Yeah. And yeah, so that's, OpenSearch is going to be adopting JVector as well. So yeah. And of course, I got to pin my thing, but if you can go use Astra for free and it's in there as well. But more importantly, take the survey. It's like that QR code, just magic. Bing. That's all I have. Any questions?
And the big thing is that it's going to be on the batch processing, right? Is there a difference between a batch processing and online?
Oh, no. I'm saying that earlier versions of vector search were batch. This is completely online. Yeah, so when it comes to online search, that is what you really want. You don't want to insert data and wait a few minutes for it to index. Yeah, so Cassandra does it immediately. Mm-hmm. Yeah.
You would like to use the JVector to build out vector search algorithms, and we were doing some RAG application. So shall we building another layer of cache to catch the results so that the query will not take so much long time when user doing.
Caching layer. All right, so I don't think your mic's on, so I'll just repeat it. What about putting a caching layer between the application and your RAG results or your vector search results?
Yeah, also I'm thinking like how's the performance like using this vector search building a RAG application like? if people would like to building a real-time chatbot application, like RAG application, is it powerful enough to do so, or should we build another layer of cache layer to do something like that?
I'm going to give you the answer I should always give is you should test it first. Because the thing about caching layers, I think caching layers are great for a lot of reasons. If you get always asked the same question over and over again, and you get a really solid 80% plus cache hit rate, great. The thing that you're going to avoid if you don't use a cache is updating of data. So because if someone changes the data behind it, especially if it's a hybrid search, then you'll have to do cache validation to make that work again, right? So if you have data that's purely static, yeah, cache could work, but we're engineers, you should test that. I mean, it's pretty fast. It's millisecond search. Yeah, so and it depends on how many terms. If you say, oh, I want 100 terms back, then it's going to take longer. But usually people want like 1 or 2 or 3 or 1.
One question. So when you do the search, is Cassandra the query hitting all the nodes, or is there an additional index to limit the query to a certain number of nodes?
Yeah, that's a good question. So does it hit all the nodes? Well, SAI, like I mentioned, is part of that. And SAI does do scatter gather, and it has some tricks. Actually, that was a JIRA that we just saw. Like if you put a predicate in front of it, like a partition key, then it won't do that. So because it's using SAI, that will help limit it. But you're still, when you're talking about approximate nearest neighbor, it does need to look at the entire vector space, and that's in memory. It does scale, and we do have, we have some tricks to make that work, and we're continuing to work on it. But scatter gather is still the thing that has to happen.
Any questions, not just for Patrick, for any of the speakers? So please bring them on.
I think video was going to grill them.
Yeah, I was gonna ask you. The embeddings that you have, you want to use the same embedding model for insertions and gets. If you want to reindex the whole thing
Oh, like a reindex?
with a different model,
Yep.
Cassandra, we have to read the whole table
Yeah,
scans.
You would have to just rewrite all that data. Yeah. So choose wisely. It's kind of you're talking about things like we're learning now that suck, right? It's like what happens if I get it wrong? Kind of sounds like data modeling. What if I get my data model wrong? But there are ways to, there's re-ranking. I didn't even go into Colbert, which is a search technique. That's a more advanced, and maybe it'll be the next one we do. But that kind of re-indexing problem is just rewrite your data. Or depending where your source data is. Yeah, you might have to do that way too. Hey, you know what would be really good? A Spark job.
Yeah, I was about to say.
Argumenting the data in Cassandra itself.
That sounds like a CEP. I know. I think it's a good idea. Like, so data stacks in our cloud service, we intercept the request to the database, and we can create the vector embedding in the request, but it's not on the database. But when you have a re-ranking or re-indexing thing, it is a rewrite of the data right now. We don't have any solutions for that. You're right. That could be a problem. Hasn't been a huge problem yet because no one's writing enough of these yet, but it will. There you go. Yep.
Chris?
So my question is actually for Dinesh, or maybe anyone if they have an idea for it. But with the passwordless MTLS authentication, one of the hardest parts about that, from my perspective, looking at it, would be the signing, the expiring, and the refreshing of certificates. Is there like some kind of open source or known ideas for like building infrastructures in to handle that kind of problem, or is it always just going to be another build from your own thing from scratch?
I would need to get back to you on this, but most of these infrastructure is probably roll your own infrastructure at this point. The only standard that we have that I am aware of, and I could be wrong, is the Kubernetes community has these spiffy identifiers for workloads in the open source, but again, like you have to roll your own infrastructure for the certificate issuance and expiry and all of that stuff.
Well, Cert Manager is the way to do it there in Kubernetes. Yeah.
Like, HashiCorp, Vault, and stuff.
Yeah, but again, I don't know about Vault as much as probably you do. But I think recently I heard about licensing changes, so I don't know how you use.
Well, with
that as-
Cassandra, we use Cert Manager to manage MTLS. So it's automatic. So it rotates the certificates. It uses Acme to do all of that. Yeah.
And is that using Cassandra's thing to hot reload those certificates too? or-
Yes, it does. Thank you very much for that. That was a really, yeah, I know, but it was that hot reload. But that's Kubernetes. Outside of Kubernetes, you have a different problem.
Okay.
Any other questions?
I got a microphone over here.
I have a question for Dinesh as well. You mentioned a mode of the Spark bulk writer where you use S3 to decouple the production of SS tables from the consumption on Cassandra. I'm curious what use cases you see that being useful for and what trade-offs you see between that and writing directly.
Yeah. So the main trade-off there is, or rather the use case that I would think is when you need to fan out to multiple data centers. And if your fan out is very large, then you just want to produce the data once and then consume it on a bunch of destination data centers.
Hi, my question is, you have very big deployments of Cassandra. So how do you manage the deployments? Do you do the deployments on VMs or Kubernetes? And what kind of instance types do you use for Cassandra? And what storage is the preference, like local disk or EBS?
We're doing a survey on that right now.
I see that question missing, the EBS versus local storage.
Is that question specific to Dinesh? He can answer.
All of you, I mean, I would just get a, how you guys use.
I don't know how much Dinesh can answer.
I can't comment as to what we do internally at Apple, though.
I'll comment because I've been watching the survey results come in. A lot of you should be ashamed. You're still using virtual machines. A lot of virtual machines, a lot of containers, and a lot of just racked up physical machines still. It's changing though. There's a lot of cloud infrastructure. So if it's not on-prem, it's some cloud, right? And it's changing. The on-prem installations are dropping like a rock. Like this year, it's just gone down quite a bit. Cloud. What are people running in the cloud? EBS, some sort of disaggregated storage mostly, and local storage per node. Those are the two things that are the most popular.
Yeah, I can answer for Netflix. We don't use VM. We don't use any of the containers, so we still run on AWS instance types like I family, M family. We use EBS heavily as well.
So at DataStax, we use a lot of Graviton servers. So then that is probably the biggest saving of money you can make. Is Graviton servers are pretty amazing, running on ARM. We also use a lot of S3 for data storage.
Do you use your own Kubernetes or manage Kubernetes?
We use our own. Yeah.
Yeah, you skip the upgrades then.
Yeah. I wrote a book on it.
We have to do every year 2 times migration from old Kubernetes clusters to new Kubernetes clusters because
I would always recommend managed Kubernetes. Yeah, no, just don't do it yourself unless you have a whole bunch of people who can spell Kubernetes. Yeah.
K8.
Yeah, there you go. Expert.
Thank you.
Any other questions? Going once? Going twice?
Thank you, everyone, for coming out on a Friday night.
You have follow-up
One
question?
more question.
Oh, wait, he's like, wait a minute.
Yeah, regarding the upgrades. So we are on 3.11. So how do we migrate to 4 or 4.11?
Go to 4, then go to 5. You
Not
need
4.1?
you have to stop at 4. You can't go from 3 to 5.
Okay,
Go to 3 to 4 to 5.
okay.
You
Yeah.
have a unpopular opinion. Counter opinion. Okay. Well,
And what should be the soak time?
yeah, there's a Jira out there. Like, yeah, you can.
Your
Apparently it's
question is
bad.
what should be the soak time
Yeah.
in each version?
When you do go from 3, like only go one major version to the next. That's just more general advice. Skipping major versions is a bad idea. Just go from, if you're sitting at a major version, go to the next major version. And if you're like 10 major versions back, one at a time.
And don't enable anything new.
Yeah. Yeah. Don't get fancy along the way. Yeah.
To answer a soak time, it depends on how aggressively you are exercising all of your code paths
Mhm.
from the application. So if you have a variety of use cases which covers most of your code base, then the time is less. If you have few applications which take longer to cover your use cases, then you would have to.
Okay. Yeah, correct.
With that, a big round of applause for all the presenters today.